already done all the first steps, figuring out what the Maclaurin series and the Taylor series. We've already integrated it. We've already done all the fun things we're supposed to do. Now the question is, where is it convergent? Make sense? Make sense? Okay, so let's do this. So I'm going to do number 11 right now. 11 is, so my pen doesn't work. My pen works, I just don't have it on the pen. That's a problem. N equals 0 to infinity. The series is x over 2 to the n. All right, so I'm going to plug in a 0, I get 0. I'm going to plug in a 1, I get 1/2. I'm going to plug in a 2, I get 1. No, I don't. I get 1 squared. Whoa, I'm being too lazy. 1/2 to the n. I missed this little n up here. It's kind of important. So that would be to the first power. So this would be 1 plus, plug a 1 in there, I get 1/2. Plug a 1 in there, plug a 2 in there, I get 1. Plug a 3 in there, I get 9. No, I don't. I get 27 2/4. Right? We're going to do it in just a second. I like looking at the series. Right? Is this a divergent sort of thing or a convergent sort of thing? Looking pretty divergent. That said, it has a kind of weird dip in here. Okay? So that question is, what values of x make this thing happen? So what's the nth term? They gave it to us. What's the nth plus 1 term? What's the n plus 1 term? N plus 1. How do I find the ratio? See, they're already giving it to us, right? They're already giving us most of the work for us.
So you don't have to do like the just f of x.
Well, I mean, you have to figure. Well, yeah. Okay. Yeah. And this is, by the way, why would they do this? Well, look, on the AP test, you have 3 minutes to do a problem, right? Can they ask you to do an interval of convergence or radius of convergence problem in 3 minutes if they start you at, hey, develop your own Maclaurin series for the following expression? They can't. A lot of what we're talking about is the actual what's really going on. On the AP test, they're going to chunk out little pieces of it, okay? Which is kind of what we're doing also. So what do I end up with? An x over 2, don't I? Now I take the limit as n approaches infinity of x over 2, which is still x over 2, right? I said x over 2, absolute value less than 1. Using the Larson method, I would go multiply both sides by 2. I get 2 is one of my bounds. I know it's centered at 0, right? Because there's no x minus 1 anywhere in my expression. X minus 2, x minus 3, or something that would make it centered someplace else. So the center's at 0, so then the other side must be negative 2, right? And that is the Larson method. Now, we're all into the Larson method apparently today. We're good? Should I go any further? We're all happy with Larson method? All right, move forward. Oh, I should not have. Whoa, what a bad human being I am. What just happened there? Okay, so now I'm going to plug in negative 2 to figure out whether or not negative 2 is okay. Okay. By the way, radius of convergence is now 2. We know that. So you're right. That's where that one stops. But with the interval of convergence, though, I now need to figure out what my 2 end bounds look like. So I'm going to plug in negative 2. I plug negative 2 in this expression, or in this expression. So I go negative 2. What the heck was I doing here? This is completely wrong. All right. So negative 2 over 2 is negative 1. So I get negative 1 to the first power would be negative 1. The next one to the second power, so that would be 1 plus negative 1. Plus 1, right? It's going to do that forever. Is that convergent or divergent? Alternating series test, right? It's changing. Is each one decreasing? No. So if you wanted to write it out, you'd say an plus 1 is not less than an. Absolute value bars, right? Therefore, this is going to be a curved bracket. Okay? On the other side, for 2, I'm going to plug in 2. I get 1 plus 1 plus 1 plus 1 plus 1 plus 1. Convergent, divergent, lasagna. Divergent, how do you know? It goes to infinity. That's fair. You could say it's an arithmetic series, right? I'm adding numbers that's got to go to infinity and they're not getting smaller or anything. You could say that, arithmetic series. I would prefer if you would say limit comparison test. Not limit comparison test, right? Now, I would prefer you say that because then you have a rationale that is flat up that's clearly divergent. Does that make sense? Lasagna good? So that's divergent, so I use a curve bracket there. So my interval of convergence from negative 2 to 2, not counting negative 2 or 2. Got it? Can do it? All right, so I have a small, well, let's see how far we get. Okay, everybody start doing 13 through 31. Let's go. I'm already doing 15. How about give everybody a chance to do 15? Everybody do it. I didn't even assign 15. So, do 13 now, but 15? Well, I did 13 through 31, yes. You're really fast doing that problem to get that. Now it's like, okay, everybody do 15, because Ms. Larson says that's hard. I'm sorry, do 15. I can't, I don't want to start it until you have a chance to do it. X to the n over n factorial plus x to the n plus 1 over n plus 1 factorial. Ratio test. X to the n plus 1 over n plus 1 factorial times n factorial over x to the n. I look, I've got an x still floating on top. I've got an n plus 1 on the bottom. Now, how do I have an n plus 1? Remember factorials, right? I'm multiplying by each number, right? So if this is 7 times 6 times 5 times 4 times 3 times 2 times 1, this is 8 times 7 times 6. So there's only an 8 left over once I cancel them all out. Okay. All right. Limit as n approaches infinity. X over n plus 1. What do I get? 0. So when is 0? What values of 0? Values of x is 0, absolute value of 0 less than 1. Always. Absolutely convergent. Not dependent at all. The radius is infinity. Centered at 0. Good? Feeling a little bit better? Getting more comfortable with these? All right, let's do a few more. So sum as n equals 0 to infinity of 17. I've got 2n factorial x over 2 to the nth. And so my ratio will be defined as 2n plus 2 factorial, right? Because I put an n plus 1 in there and distribute 2 through. Is that okay? So it's 2 steps. Is that okay? Seriously? Okay. I'm going to make sure. And then this is x plus 2 to the n plus 1 all over, or I should flip. And let me put it at the bottom. 2n factorial x plus 2 to the n. Did I make a mistake? We're good? Okay, so if I play this game, now what's interesting about this is this has 2 more terms, right? So there'd be a 2n plus 1 and a 2n plus 2 left over. Because there's 2 more terms than the previous one. Is that okay? Because if this was 8 factorial, then this would be 6 factorial, right? Okay, well, see, it was 2n, right? So it's 2n. So we're going up 2, 4, 6, 8. So this would be like 8 factorial over 6 factorial. When I cancel them all out, I end up with an 8 and a 7. I end up with the last 2 terms available. In other words, I got 2 more than this, so there'd be 2 more terms. One would be 2n plus 1, the other would be 2n plus 2, right? Is that okay? That's what I really needed to explain, because that's not obvious, at least where most people come from. To the, just x plus 2, right? I'm sorry, one more time? Yeah. 8 and a 7. 8 and a 7. Or a 10 and a 9. All right. So now I'm going to take the limit as n approaches infinity of 2n plus 1 times 2n plus 2 x over 2. What do I get? Infinity. And infinity is less, the absolute value of infinity is less than 0, less than 1 when? X is what?
Never.
Never. So this has 0 radians of convergence. And there is no interval of convergence. In other words, don't ever use this to approximate anything because the garbage is at the ends. Whatever this ugly thing is. Which makes sense. All you're doing is multiplying by a factorial each time. Should be getting pretty big pretty fast. Yes, sir?
For that, would you say that the radius of convergence is 0, or would you say it's something else?
Well, you can say there's no radius of convergence. It's probably safer to say that.
Yeah, because I was
it's safer to say that. You're allowed to say 0 radius of convergence, which means there's no place it's convergent. The problem with that saying that is that you would, then the question is the middle point convergent or not? But the middle point is an endpoint, and the radius of convergence never deals with an endpoint. So therefore, you're allowed to say that. Would I say that? If I could avoid saying that, I would. Be aware, though, they might easily write down the radius of convergence is 0. And what they mean by that is there's no place it's convergent. And so they are allowed to do that. So it's good we're having this discussion because they could go either way. More likely, they won't ask a radius convergence problem in this case. They just wouldn't, just avoid, you know, the angry letters from some teacher who come on it, taught it one way. Their book says it's that way. What are you guys doing over there?
Because that's something applies.
Well, yeah. The problem is radius convergence is a different idea than interval of convergence. I put them together really cutely, but the radius convergence is the idea of how much convergence there is in the system. And by saying 0, I'm actually answering that question. So it's one of those, you'll probably find 3 textbooks that disagree exactly what's the best way to say this is. And that's why I said I don't think you're going to see this on an AP test on this sort of a problem. You'll see it on the other kind, but you'll see it on this. Stop.